All right, so transition matrices is our last section that we're looking at. So what are the first two sections that we've looked at so far in our topic? Dominance. What else? Connectivity. Cool. And so our third and final bit is transition matrices, okay? This section's slightly different because you know connectivity and dominance were linked, weren't they? There were some similarities. Can anyone tell me what like a similarity is between those two topics? Like what was sort of similar between those two things? Did you notice anything that was the same? Were there any similar? Yeah. Pathways, yeah. Pathways, connections, that was similar, sort of built on it. What else was similar in those two topics? Were any numbers the same? Like were there ones and zeros? Did the matrices have ones and zeros? Yeah, we did that. That was pretty similar, wasn't it? This topic here still has matrices, but the calculations and things is a bit different, all right? So it's sort of a slightly different tact. So, I mean, it's, so how we're going to learn it, if you actually have a look at your booklet and how we're going to learn it, it's the first page, it sort of dives straight into an example. And then the next bit, we dive into another example again. And then have a look at page 6. Can you sort of see page 6? Page 6 is where I'm actually going to give you the theory. So I'm kind of going to teach you this in a bit of a different way. We're going to learn it by looking at an example. All right? We'll look at a couple of examples and then put together the theory on it. So just stay with me as we do that, if that makes sense. All right, and hopefully you'll like notice and see the patterns as we go. Okay, so can we grab your pencil? Can I highly encourage you to use a pencil when you're doing transition matrices, because then if you make an error, it's easy to change it. If you don't have a pencil, use a pen, okay? All right, let's have a look at this example. Xenon, it's a paper supplier. Everybody say Xenon. Oh, that was so enthusiastic. Everybody say Xenon. Oh, Mrs. Briggs, they're so enthusiastic. The table shows the percentage of customers who choose each week between Xenon and its competitors. So let's understand what this table's all about. So this week, let's look at that first row. This week, 80% of people who buy Xenon this week are going to buy Xenon next week. But 20% of people who buy Xenon this week are going to go to their competitors. You know, somebody else, a competitor like a different paper brand. What does that second row mean? The second row, could somebody describe that second row using some words? Brad, let's see if you, could you explain to me what that second row means?
So this way 10% of the competitors are going to use Xenon, and next week 10% are going to use Xenon as well.
Yeah, that's it. 10% of the people who are using competitors this week are going to actually change to using the other brand. All right? So a transition matrix is going to show this behavior of like change from one thing to another. Okay? This is paper supply, but there's heaps of other examples of where we can see like transition behavior. Like if you were working for Woolworths and you were going, what can we do to be able to keep people coming back to Woolworths week on, week out, rather than switching to a different company? You know, like, but let's be real, people sometimes stay with the same grocery shop, don't they? But sometimes they change. We can see transition behavior in lots of different things. But this one we're going to start. All right, transition behavior. Label it T. Any guesses as to the dimensions of this matrix? 2 by 2, it's correct, it's a 2 by 2. All right, we're going to label it, it's going to go from Xenon, competitor, X and C. X and C standing for Xenon and competitors. Let's label it this week. And let's label it next week. Okay, our transition matrix shows those percentages, but we need to put it in decimal form. Decimal form is the key here. So 80% is equal to what out of 100?
0.
Yeah, it's 0.8. You've jumped straight to it. So we would put 0.8 there. I can't see that number, but I think it's 10, is that right? So 0.1, 0.2, 0.9. All right, let's put our first note, and feel free to use a different colour pen for this. Decimals. Needs to be in decimals. And what do you notice about each row? Adds up to 1. All right, so the row adds up to 1. There's no pattern with the columns. Spoiler alert. Sorry for that. Okay, in the matrix T, state the meaning of the element 0.2. So the 0.2 is here. That's representing 20% of people who buy blank this week will buy blank next week. There's 2 blanks there. Can we fill in those blanks? Ms. Coggins, what are the 2 blanks? 20% of people who buy...
20% of people who buy Xenon this week will buy consistence next.
You got it. Perfect. Can you have a go at writing a sentence to answer part 2? Who's got a sentence for me that they're willing to share? Josh, you give it a crack.
That 90% of people who buy competitors will also buy competitors next week.
Yeah. All right. Can we go on to question C? Initially, Xenon has no share of the market. Think back to ABW when we looked at like market share and percentage market share. So this is saying initially nobody was buying Xenon. That's what it's saying. So the initial market share row matrix is S. Now it's not to the power of 0. It's like sub 0. Subscript 0. So the initial market share is 0, 1, which means the first one is obviously representing X and the second one is representing the competitors. So initially 0% of people were buying Xenon, 100% were buying the other stuff. It says calculate S0 times by T and interpret your answer. So what we're going to need to do is we're going to need to calculate that, which is this times by this. We're going to calculate that and then we're going to interpret it. Now to calculate that, we'll be using our calculator. Let's go into our matrix section. What I'd be encouraging you to do for this is to, I'm going to unfreeze it. Whoa, just throwing things around here. I'd put S0 as a 1 by 2 matrix. So enter that in. And you then have to sort of remember, oh, okay, I've put S0 as A as my A matrix. And then I'd be putting matrix B as my 2 by 2 matrix and filling in all those details. Now, some of you who are good with your matrix multiplication probably could have just done that by hand in that time that you've entered it in, but later in the question we're going to need that. We're going to need the power. So I've added T as matrix B. So, or did I do it all right? Did I enter things? I think so. So what do I do to work out S0 times by T? What am I going to enter into my calculator? Yeah. Shift mat alpha A times by alpha B. Yeah, good. Alpha B gives us our answer. Point 1, 0.9. We're going to answer there. Let's have a think what we've just done here with this calculation. We've got the initial state and we've times it by this transition behaviour. What was this transition behaviour telling us? It was telling us how everything changes from week to week. And we've just times it by the transition matrix once. So what this now shows us is the percentage of people who buy each product in how many weeks' time? Next week. Yeah, it's 1 week. So initially, no one bought Xenon and 100% of people bought. But the competitors, after 1 week, 10% of people are buying Xenon, 90% of people are buying other products. I think that's what it asks us to do, isn't it? Interpret your answer. So the interpretation after 1 week, 10% by Xenon, 90% by competitors. Any questions so far? All right, question D. Question D asks us, find Xenon's market share after 2 weeks. What calculation are we going to need to do to find out the market share in 2 weeks' time? Can anyone hazard a guess? All right, turn to the person next to you and make a prediction. What do you think it is? What would the calculation be? Have a guess. All right, good thinking. Who's willing to have a punt? Who wants to have a guess? Is that you, Flynn?
No, I think Brad came up with Brad.
Brad came out with it, yeah. What do you think? Let's brainstorm. What do you think? T squared? You reckon T squared?
T is up 1 week, T times 2T. Oh, sorry, 2T, not T squared.
So that's the question. Is it 2T or is it T squared? What did we do here? We times it by T. So if you're wanting to do it after another week, you'd times it by T again. So it's going to be T squared. What's it going to be after 3 weeks? T to the power of cubed. All right, so are you picking up the pattern? So what are we going to need to do? S0 times T to the power of 2. S0 times T squared. Good. So what am I going to need to change in my calculation here? What am I going to need to change in my mat A times mat B?
B.
Make it B squared. Good. It's hip to B squared. Oops, what have I done there? It's hip to B squared. All right, I've done it. Oh, syntax error. What's going on? Because that log is there. Now I got 0.17 and 0.83. Have we answered the question? No. What's the question asked us? Find Xenon's market share after 2 weeks. Which number do we care about? 0.17. In other words, we need to change it to a percentage, so it would be what percent? 17%. So after 2 weeks, Xenon has 17%. So there's a lot going on the board. What about part 2? Part 2 said after 4 weeks. What's our calculation going to be? Yeah, to the power of 4. So it's going to be S, the initial, times by T to the power of 4. Notice again, it's S subscript 0, so it's like the initial. It's not to the power of 0, because anything to the power of 0 is 1, right? It's just saying initial. So S0 times T to the power of 4, let's recalculate that. Ooh, what do you notice? What's happening to Xenon's market share?
It's decreasing.
Is it decreasing? Xenon's the first one, isn't it? Ooh.
Yeah, it's increasing.
How do I change 0.2533 to a percentage? How do I change it? 25.33%. Move the decimal spot 2 spots to the right, all right? 2 to the right. As opposed to Beyonce telling us to the left, all right? Okay. So Xenon's market share is increasing. Can I go to the next question? Next. Oh, there we go. All right, now what it's asking is calculate T to the power of 30. Oh my goodness. T to the power of 30, how are we going to do that? What are we going to type into our calculator to work out T to the power of 30? Shift, Matt. Yep, so we're basically doing matrix B to the power of 30. Let's type that in and let's see what we notice.
Big number. That's a big number.
Chicken burger.
Chippies. 0.323483596.
Let's round to 4 decimal places here.
33333.
What would it be to 4 decimal places?
3.33.
It's lots of 3s, isn't it?
0.33.
And what would our next one be? Remember there's that little arrow there? 0.666. Now remember what this means is we've got X to X. So that means people who bought Xenon this week, 33% of them are going to buy Xenon next week. Now this 0.33 here means people who bought competitors this week, 33% are going to buy Xenon next week. Remember this one here, X to C is 66%, C to C is 66%. So do you notice that both of these columns are the same? What mathematicians have noticed in transition behaviour is that if you model something with transition behaviour, in the long run, the percentages and the variations head to what's called a steady state. In other words, despite there being change and difference, in the long run, a certain percent buy one product, a certain percent buy another product. And yes, maybe people within it change, a bit like the supermarket example that I mentioned earlier. You know, like generally, the percentages of people who are buying at each store is pretty even each week. So what this is it's showing us the steady state. So that 30 is saying after 30 weeks, isn't it? I want you to have a play, change it to a bigger number. So change it to, rather than 30, change it to 40 and see what the percentages are. Change it to 50, see what the percentages are. Change it to 100, what do you notice?
number gets more and more accurate.
We're getting closer to that 0.333 figure, aren't we? Do you notice that? See, I just did b to the power of 250. So, Nikki, what do you notice about that?
It stays the same.
Stays the same. Yeah. So, could you fill in this for me, I was about to call you Xenon. Nikki, in the long term, what percentage are buying Xenon and what percentage are buying the competitors? 33%? 33.33 and 66.67% are buying the competitors. All right? Or you could say 33 and 67%. We're not going to disagree on that, are we? That's just rounding, okay? But when we're doing these calculations, there are some assumptions that we're making with mathematical modelling, and let me give you two of them. We are assuming that the same people are buying paper each week. In other words, mathematically, we're assuming that the same people are in the model each week. We're assuming that. I guess we're also assuming that there's no significant disruption to the transition behaviour. There's no significant disruption to the transition behaviour. Can someone translate that for me? What do I mean by that? Yeah, Flynn.
The matrix T will stay the same.
The matrix T, that transition behaviour stays the same. Yeah, good. What else does it mean by that? There's no significant disruption. Means something like Xenon. Imagine if Xenon had some big business crisis and it turns out that they were actually went bankrupt and they went out of business and so people couldn't buy that. Those types of factors as well. So assuming that that's still remaining the same, okay? So when we're looking at transition behaviour, the kind of key general assumptions is that the people within the model are still staying the same from week to week. Nobody stops buying paper. Let's be honest though, paper purchasing is probably on the decrease, isn't it? We're still keeping it in business today, a bit. All right, questions or comments on that so far? Can we have another look at another example? Let's have a look at one more example and then we'll put together our formulas to actually see it, all right? Whoa. All right, this one I've stolen from the textbook, so it wouldn't stress me out if you want to open up your textbook and have that with you as we go along, but we'll do it here together. This next one is, at a local high school, 30% of students who bring their lunch from home on one day, can you underline from home on one day, will buy their lunch at the canteen the next day. 50% of students who buy their lunch at the canteen on one day will bring their lunch from home. All right, we need to construct a transition matrix T for this situation. What size is our transition matrix going to be? 2 by 2. It's going to be a 2 by 2, yeah. Why is it a 2 by 2? Canteen. So home and canteen are our two categories, aren't they? Yeah. I'm just going to look at my answer that I prepared earlier and see whether I put home first or canteen first. It doesn't actually matter whether you put home or canteen first. The calculations will still work out. It just might, where the answers are. I put home first and canteen second. Could we do that? From, to. All right, so let's look at our information that we got there. Love. Here we go. All right, that first bit of where am I going to put the 30%?
The first one.
The first row?
Yeah.
Left or right?
3.
Where am I going to put it, here or here?
The left one. First one.
30% who bring their lunch from home will buy their lunch at the canteen the next day.
So then it's not.
So home, so it's not
Is it
the
right?
It's going to be top right. Yeah. Then the next bit, 50% bottom left, canteen to home. 0.5. Now we've got to fill in the gaps. But Mr. Worley's given us a dud question because there's 2 bits of information missing. Remembering the transition matrix always adds up to 1 in each row. So the row adds up to 1. So that's going to be 0.7 and 0.5. Row adds up to 1. Okay, next question. On Monday, 400 students, can everyone circle 400? 400 were surveyed, 243 brought their lunch from home, while the remainder brought their lunch at the canteen. Construct an initial state matrix. Is our initial state matrix going to be a row or is it going to be a column? Have a look back at what our previous question, what did we do in the last one? Was it, you reckon row? It's going to be a row. What are the dimensions of that row matrix going to be? 1 by 2. It's going to be a 1 by 2 because we're going to have home and we're going to have canteen. Right, so how many people got it from home? 243. How many from the canteen?
157.
But where'd you get 157? That's not in the information. Good. You had to do this. You had to go 400, take away 243. All right, good. Okay. All right. Got to have your handball ball to finish that. Okay. All right, question C. How many students do you expect to buy their lunch at the canteen on Tuesday? What's our calculation going to be? This is Monday. What are we going to need to times that by?
By the T.
By the T. So we're going to need to do, for this, S0 times by T. So again, on your calculator, going to need to reset things up. Tanya, what 2 things am I going to need to change on my calculator? B and so I'm going to need to go change my matrix B. Let's do that first. So here's my matrix B. Let's change that to like 0.7, 0.3. Oops. Now Tanya's very correct in I'm changing that. What else do I need to change? Anything else? SO, the initial state matrix. So I'm going to need to go up to matrix A and change that as well. Oh, they're not away today because they were at Taylor Swift, are they? Is that the reason why they're... No? No one got... I worked it out because I was like, if there are 280,000 people who were at that Melbourne concert, 280,000 divided by 25 million Australians, there should be 10 Emmaus students who have gone to it, if you did it proportionally.
Wait, that's actually really cool.
So let's... Did I do the right maths? 280,000 divided by 25 million Australians times by 900 Emmaus students. Yeah, 10. 10 students if it was evenly proportioned. But there's double that because there were the Sydney concerts as well. So really 20 of our students should have gone. Sydney hasn't happened, yeah. So I'd be disappointed if less than 20 of our students got tickets for it. That would be my yeah. Anyway, okay, we digress. Didn't try for okay. Okay. What assumptions are we making? Everyone's keen. Everyone gets through. The Ticketek website didn't die while you were sitting during your maths faculty meeting trying to get Taylor Swift tickets. That's just me. Okay. What do we do next? We need to work out S0 times by T. So what am I going to need to type into my calculator? Shift. Good. Times by shift mat alpha b. Sorry for our Taylor Swift diversion there. Okay. Did anyone else get decimals? I feel like I've done something wrong because there's decimals. Yeah. Now we know in reality you can't have 0.6 of a person and 0.4 of a person. Maybe in reality it's that. Which one's the canteen? Is the canteen this or is the canteen this one here? The canteen's on the right. So what I'd like to see you doing when you interpret that answer is to round it to a whole number. There you go. Therefore, predict 151 people buy from the canteen. Please don't predict that 151.4 people. Like in a worded question in general maths, when there's a decimal answer for something that can't be a decimal, you need to round it. Like if that was a test question, you'd lose half a mark if you didn't round it. Okay? All right, mate, but look, if you wrote your little comment that you wrote there, Brad, about that there, you'd probably then earn the mark back. All right? Okay, if you're going into that much effort to explain it, you're right. Great. Okay?
What did you say? I said that there's just one kid that decided to bring lunch and
By half of it. What calculation am I going to need to do, people, to work out the Friday calculation? It's going to start with S0, isn't it? S0 times by T to what power? 4. Yeah. Because it's 4 days later, isn't it? Yeah. To the power of 4. All right, let's do it again. What's it going to be? There we go. Do I have somebody to second my answer on the board? Have you ever heard that phrase before, to second something? If you're in like a meeting, maybe if you've been to like one of your sports clubs, AGMs or something, and you have to, if you're like seconding something, it's like, I agree to it. Yeah. So Nikki, do you second my answer? Yep. All right. How many people would buy from the canteen on the Friday then? 150. And that poor 0.01 of a person, all right? We won't bring up that discussion of, a 0.1 of the person. Okay, next. Can we go to part D? We've got 2 questions to go. Can I clear the board? Permission to clear the board? Yep. You're doing well. Okay, it says, find the steady state proportions of students who will buy their lunch at the canteen. Steady state proportions. What did we notice in the previous question? How did we work out what the long-term percentages were going to be? What did we do to matrix T? Yeah, we did it to power of 30, didn't we? Power of like a really high power. Why don't we just try doing it to the power of 50 and see what happens? Again, have a bit of a play. So I did to the power of 50 and I got 0.625, 0.375. Does it do that for 30 as well? Percentages we don't need to round, do we? Or do you notice even to the power of 30 did that as well here? So it reached the steady state. Same thing. Sometimes your calculator can't do those really big calculations. But look, it's done. We can blame our technology. All right, who can interpret that for me? What's the interpretation? 62.5. What is? So. Oh, that's it. Yeah, good. All right. Thank you for keeping us on point. Here we go. Good. So we don't need to even worry about that. So what's the canteen stuff then?
37.5%.
So in the long term, all it's asking for is the canteen. So in the long term, as in the long run, like overall, eventually 37.5% of people buy it from the canteen. All right, what are two assumptions that we're making when making that calculation there? What are some?
So everyone will buy.
Same school? Like, yeah, same students?
No one gets sick.
Yeah.
Prices and food at the canteen don't change.
All right. Now it does. Good. You're more than welcome to add more than that. All right.
I'll say that 101% on my case. I'm just playing this out.
All right. I phrased yours as prices at canteen don't change, causing transition behaviour to change. Is that what you mean? Like, now, you can, if that was a test question and it says state two things, you can state more than two, but here's how it works. If one of them's wrong, you like lose the mark for it.
Yeah.
So if two of them are correct, but then you go on and put a third one and that's wrong, I give you the 2 marks, but then you lose the mark for the incorrect one. So you only end up with 1 mark. Okay? So, yeah, if they're all right, do I give you the extra mark? Yeah, like I can't. Sorry. Just 100 marks for that question. I wish I could, hey? Like you're just such an expert on assumptions. By the way, chuck into ChatGPT about, like ask ChatGPT to give you some assumptions about these contextual questions. They'll give you some good ideas as well. Yeah, unfortunately they're red tasks, so we can't get you to, yeah. Okay, whoosh, all right. We're all done. We're now ready to basically look at the theory. Remember how I was teaching you that I'm going to flip it? We've kind of actually looked at the theory, but can we try and summarize this now into 1 page? All right. All right. So let's try and summarize this theory. An example of a transition matrix. What's an example of a transition matrix? We've made some up, haven't we? 0.2. Here's my transition matrix. What number is missing at the very bottom right of that transition matrix? Good. We haven't looked at it yet, but you can have transition matrices that are like 3 by 3 or 4 by 4, like higher order transition matrices. The initial state matrix is a row matrix, for example. I don't know, let's just make one up. 100, 200, 300. All right. To work out the proportions. Oh. Sorry.
Where you just go flat.
I missed that. All right. To work out our proportions, to find the proportions after 1 week, you just do t to the power of 1. After 2 weeks, it's t squared. After 3 weeks, it's t cubed. Was that everything you hoped it would be and much, much more? Yeah. The ball, like, yeah, was that? Yeah.
No, it's what he said after.
Okay, I don't. T to the power of 5, t to the power of 10. What would I put here? T to the power of 15. T to the power of n. And then to find the number after a certain time period, you times it by the initial state matrix. So S0 times t. S0 times t squared.
Why is there so much writing?
Why did we skip 4?
Because you went.
What did I skip?
Like you went T1, T2, T3, and then T5.
I guess I'm showing the pattern. See how it's like 1, 2, 3, 5, 10, 15. Yeah.
Because you can't do it, but you can't do it.
You can't, it is possible. Yeah, maybe it could. Do you guys notice, is maths probably the subject where you do the most handwriting?
Yes.
Is like maths,
I
do
do
you,
less handwriting in English.
yeah, right. You do more handwriting in maths, yeah.
I don't have an English book, so we're always going out last.
It's all laptops, isn't it? Yeah. I feel like maths is keeping up the stationary business. Okay. Okay. All right, let's fill this in. Given an initial state matrix, what's the abbreviation that we give to the initial state matrix? It's not I. S, good. It's S with the little 0. And a transition matrix, capital T. The state of the system after n weeks is, what's the formula for what it is after n weeks? SO times by t to the power of n. Good. You have to do times by t to the power of n. Now, people, trust me on this, and you can go away and look at it. It matters which order this is in. You have to do the SO first times by t to the power of, okay? Because of matrix multiplication rules. This is like a recap from year 11. With matrices, you know, in life, like in normal times multiplication, 3 times 8 is the same as 8 times 3. You know, like that's the thing. 3 times 8 is the same as 8 times 3. In matrices, that's not true. In matrices, matrix A times matrix B isn't always the same as matrix B times matrix A. Like it doesn't work. And that's year 11 matrices, so we don't have time to really go over it. If you try to do it the wrong way around, it might come up with like an error. And you know, so if your calculator is ever saying an error when you're multiplying matrices, it's probably because you need to switch the order. Or you've messed up bad, all right? Yeah. Okay, next we've got a couple of dot points to go. When there is very little change in the values of the state matrix from one state to another, we say that the system has reached the... I've messed up my spelling there, haven't I? Sorry about that. There was a 2-word phrase that I gave to that. What was that 2-word phrase that began with the letter S? Steady state, yeah. It's the steady state. Steady. SS. If it helps you to know that. SS. To calculate the steady state, what did we do to work out the steady state? Yeah, we did the transition matrix to a large power. Yeah. Calculate, let's just say t to the power of 50. t to a large power. And what were some of those general assumptions that we were making with transition matrices? Weather?
In a footy game, whether it's slippery or...
Good, that's a good contextual one. I really like that. Like that's a really good specific contextual one. Can we start broad though? Like things that are like, that are regular for all transition matrices things. Time? What about time?
It can differentiate. If you play at night all day.
So you're assuming that the conditions stay the same? Is that's sort of what you're leading? Like is that a broad, general,
Yeah.
Yes.
like same conditions? We also looked at,
Oh, it'd be like the same people.
yeah, same people. Same people within the model. So same people within that transition behaviour. Same conditions, same people within the model. Another really broad one is that,
No disruption.
yeah, no disruptions to transition behaviour. Transition B. So there are broad assumptions, but again, if it was like a test question, you need to make it specific to the context. So please don't, in a test, just write something straight from your cheat sheet. In fact, the end of year exam, this isn't going to be in the exam, this topic isn't, because we know our end of year exam is only on stuff from the third topic onwards. But if you just write a general thing that they can tell has been written from a help sheet, they're getting really tough in the exam at the end of the year. They don't give you the mark for it. It's got to be really specific. So, like, for example, on that canteen question, if you said something about, oh, we assume the same students are going to be there each week. Yeah, that's good. You know, that's something specific to the context. But don't just write, oh, we assume transition behaviour doesn't change. It's not specific enough to the context. Or don't just write same conditions. Like, you know, show that you really know that concept. Does that make sense? All right. We've just covered a fair bit at the end of the day. So give your neighbour a pat on the back because for the end of the day, that's actually pretty good. All right. In our next lesson, and we don't have time to play with, in our next lesson, we'll have a play with the next question, all right?